Okay, let's get started. We want to simplify the following expression and write answers with positive exponents. And if you want to ask any questions along the way, just go ahead and ask the questions in that chat box over on the right hand side. So we have a times b squared times c raised to the negative 3 power divided by a to the fourth and then b to the negative 3 power down below, and that whole quantity is squared. So taking a look at this, how do we actually go about it? Well, usually what we do is we start with the parentheses and kind of work from there. So this whole quantity is equal to, let's work with that first set of parentheses. You'll have a to the negative 3 power, b squared to the negative 3 power, and then c to the negative 3 power. And all that is over a to the fourth, b to the negative 3 power, and we're squaring this whole quantity. So moving forward from here, we can just use some laws of exponents. First we'll have a to the negative 3, and then we'll have b, and then when you go squared times that negative 3 power, or raised to the negative 3 power, that becomes b to the negative 6 because you multiply the exponents up there. Okay, and after that we have a c to the negative 3, and down below a to the fourth and a b to the negative 3, and this whole quantity squared. And you might say we want to square it on through, and you can do that, but what I'd recommend is working inside the parentheses first. It'll make your life a lot easier there. So the way we can work with this, when you see the variable matching, so the a's for example, laws of exponents say we can just subtract the exponents. So this becomes a to the negative 3, and then we subtract the exponent in the denominator, so that goes minus 4. For the b, we start with a negative 6, and then we have to subtract, don't let your eyes fool you, that's a perfect subtraction symbol right there. Subtract the negative 3. And then c, there's nothing down below for the c, so you just write c to the negative 3, and we're going to square this whole quantity. Okay, so what happens? Well, moving forward from here, we have a to the negative 7, and this would be b, when you go negative 6 minus the negative 3, that's negative 6 plus 3, so that's b to the negative 3. And then we have a c to the negative 3. And we're squaring that whole quantity. So if we want to move forward from this spot, now we're ready to work with using that exponent, and we're going to multiply it on into each term. Essentially is what's going to happen. So this becomes a to the negative 7 raised to the second power, b to the negative 3 raised to the second power, and c to the negative 3 raised to the second power. And you heard me mention multiplying this on m. The reason why is laws of exponents means this negative 7 and 2 we need to multiply, so you get a to the negative 14. Negative 3 and 2 needs to be multiplied, so that becomes b to the negative 6. And c to the negative 3 power squared, that becomes c to the negative 6. Okay. Well, what is the problem state? It says write these with positive exponents. So in order for us to do that, the easy way for us to go about finishing that off, we can write the first term as 1 over a to the 14th. That's all it means when you have a negative exponent. It just means 1 over whatever the term is there. And so as you hopefully can guess it, that's 1 over b to the 6th, and then times 1 over c to the 6th power. And if we wanted to put this all over one fraction, you'd have an a to the 14th, a b to the 6th, and a c to the 6th all appearing down in the denominator. I know it freaks some people out from time to time if you have fractions and all that stuff, but we got to get used to them, and so that's why you're going to see a few of these problems having fractions. So, okay. Oh, one little side note. So what we use, that exponent law, we use this fact. If you have x to the m raised to the nth power, that's just x times m, x raised to the m times n. Don't confuse that with x to the m times x to the n, which is equal to x to the m plus n. So those are just some exponent laws that we really exploited here. The only other one that I can see that we kind of worked with is if you have x to the negative n power, that becomes 1 over x to the nth power. So that's all we're using over and over, and that's how you can simplify those expressions. Now let's move to a different one. Another thing that starts to scare some people is when we have roots of this nature. So you see this, it looks like a square root symbol, but with that 3 it actually means what we call a cube root. Okay, so we have the cube root of 8, and then we have x to the 6th, and then we have this 125 in the denominator. Well, an easier way for us to break that up, this is actually the cube root of each part. So this is the cube root of 8 and the cube root of x to the 6th all over the cube root of 125. One thing to take note of here, so I'll make a note of roots. So if you have an nth root of x times y, doesn't matter if it's a square root, cube root, fourth root, whatever the root is, you can always break that up into the nth root of x times the nth root of y. However, the big mistake that we see oftentimes, this, if we have a plus symbol in between, we cannot break that up into the nth root of x plus the nth root of y. And I'll give you an example, and we'll kind of come back and solve this problem. So the example is, say we had the square root of 9 plus 16. Notice that equals the square root of 25, which equals 5. However, the square root of 9 plus the square root of 16 equals 3 plus 4, which equals 7. Notice these two numbers are not equal, kind of illustrating that this nth root property, they aren't going to be equal. So that's a common error that we see over and over again in algebra. I just want you to be aware of it. So, but we do have multiplication in this case, something to take note of, and so we can break it up as we had above. And when we have a cube root, what that means is when we take the cube root of 8, we're looking for what number are we raising to a power, to the third power, to get 8 essentially. And we have a question too. So yeah, there is a live stream tomorrow as well for calculus. Today it's college algebra. So for those of you kind of checking in, we have different live streams going on different times, so for multiple classes. But yeah, any of you having questions along the way, just let me know. So moving forward with this one, so this is college algebra, by the way, for those of you wondering. We have the cube root 8. So another way to write that, 8 is just 2 cubed, and that'll come in handy later. And we have the cube root of x to the 6, we'll leave as that. And hopefully we can kind of guess as to what power cubed gives us 125, and you'll notice that the cube root of 125 is just 5 cubed. So moving forward from here, what do we have? Well, the cube root of 2 cubed, one thing we can also write as the nth root of x. So here's another little side note, and this might help us out. If you have the nth root of x, another way to write that is x to the 1 over n power. And why that comes in handy, you can think of this as 2 cubed, if you don't recognize what's happening here, to the 1/3 power. And this is x to the 6th to the 1/3 power. And now this is 5 cubed to the 1/3 power. Okay. Well, using those exponent laws that we talked about on the previous problem, this is 2 to the 3 times 1/3. This is x to the 6 times 1/3. And this is 5 cubed, and then so that becomes 3 times 1/3 up in the exponent. Well, 3 times 1/3 is just 1. So this becomes 2. 6 times 1/3, that's just 6 divided by 3, so that's x squared. And since we're always squaring it, we don't have to worry. Sometimes you have to worry about positive, like taking an absolute value, but since you're squaring, it always turns into a positive value, so we don't have to worry about that. And down below we have 5. And so that's our final answer for simplifying this thing right here. Okay, 2x squared over 5. A lot simpler than what we saw with the cube roots and all that nasty business. Okay, moving on to the next question. Simplify the following expressions. So now we have a series of linear equations. Just want to make sure we're on the same page when it comes to just some algebraic techniques and things of that nature. So in this case, we have 9x plus. Notice the parentheses. Let's do what's inside the parentheses first, since those things can be simplified. 2 plus 3 is just 5. Okay, so then we have minus 4 times. Well, we have 2 x's, and then we have another 3 x's. Well, notice that makes 5 x's. Okay, so this is equal to, well, and then the next step, 9x. Now we can multiply this on up. So 5x times 4x makes 20x. Negative 4 times 5x makes negative 20x. Well, notice the 20x's will just cancel because you have a positive 20x and a negative 20x. So those two things just cancel, and we're left with just 9x. So hopefully that was fairly straightforward. If not, let me know. As I said, at any point in time, there's a chat box there. You can ask any questions that you have. That's what I'm here for. And if you have a problem that you want to see, let me know, and I'll try and solve that as well. Next one, factoring. So factoring the following polynomial, factors come into play quite a bit, and they can help us out. We can solve problems a lot quicker if we know how to factor. So for factoring, you see how you have a 2x squared, right? And so what that tells us right out the gate, since the only factors are 2 and 1, and we need to get an x squared, we need an x here and a 2x here. And when we multiply the outside, or the first times the first, you get 2x squared. So now the rest of it, what we have to do is try and break this down and find this missing piece. And we'll have to deal with pluses or minuses. And we need these two numbers to multiply to 15. And so what you might want to do is you can write out the factors of 15. And so you can have either 15 and 1, or 3 and 5, right? Or, granted, you could do, my apologies, we had negative 15. So you have negative 15 and 1, you have negative 3 and 5, you'd have negative 1 and 15. I gotta be a little bit more careful here. And negative 5 and 3. Okay? So we have our factors of 15. Now where do we go from here? Well, we got to think about when we multiply 2x times one of those factors and add that to x times the other factor, we need that to sum to negative x. So it's kind of a guess and check type of thing, but when you look at some of the numbers that we're going to need to work with, we want the negative x. So let's try this. Let's see if we go negative 3 here and we go positive 5 from our list. So we could maneuver them around, right? You could have negative 3 over here and positive 5 over there. There's some guessing and checking, but over time you start to learn how to work these out fairly quickly. And so we go, if we're trying to double check our work, go 2x times 2x, that gives us 2x squared. Okay, and so I think the FOIL method goes outside times outside, so we go 2x times negative 3, so that would be negative 6x. And then we go inside times inside, so that goes 5 times x, so plus 5 times x. And then last times last, so go down that way, that would be minus 15, which we should always have that last number match to. So notice this becomes 2x squared minus, when you go minus 6x and then plus 5x, that's a negative 6 plus 5, that makes minus x, and minus 15. That matches what we had up above. So the way to factor this thing is just 2x plus 5 and then times the quantity x minus 3. Okay. Alright, moving on to the next question. We want to factor the following polynomial. You have y cubed plus 2y squared minus 9y minus 18. So something a little bit different here. We have a cube, right? So you might not know, okay, how do we break this thing apart? Well, when we're looking at these, some of the techniques that we have early on in algebra is grouping. And what I'd recommend is actually grouping the first highest two powers together. So y cubed plus 2y squared. And the second two. What we'll do on the second two, though, since they're both minus, I'll factor out a minus from both terms, and we can write this as 9y plus 18. And the reason why is when we distribute this minus sign, the negative times the positive makes it negative in that second term. So keep that in mind. Taking a look at this, now what do we have? Well, the first term, what's in common between those two things? Well, it looks like a y squared. And so we'll factor that out. So we're left with a y squared times y plus 2, that quantity there. And the reason why, when you go y squared times y, you get y cubed, which is that first term. And then when you go y squared times 2, you get 2y squared, which is that second term. Minus. Now, what can we pull out of both of these terms? Well, notice 9 is in common with both of those. So you get 9. We factor that out. What are we left with? Well, when you factor out a 9, we're left with a y, and then because you have 9 times y gives you the 9y, and then 9 times what will give us 18? Well, it's going to be 2. Well, this tells us something. We have y plus 2 in both factors. So notice you have y squared of those y plus 2 factors, and then you have negative 9 of those y plus 2 factors. So what we can do is we can factor out a y plus 2 from both of those first two terms. And I'll draw a bigger parenthesis so we can see what's happening here. So how many things were times y plus 2 in the first term? Well, it's y squared of those. So we have y squared. And then in the second term, how many things were times the y plus 2? Well, it's negative 9 of those. So we have y squared minus 9. Now, we can actually break this down even further. And let me put some equal signs in here. You have that y plus 2. And y squared minus 9 can factor down even further. The way y squared minus 9 can factor down, well, let's just recall your difference of squares. You have a plus b times a minus b equals a squared minus b squared. So that's just the difference of squares, right? And in this case, we have y squared, so y has replaced a, and 9, which is, if you recall, just 3 squared. So the way we could break this apart just goes y plus 3 and y minus 3. And this is a fully factored form of what we had up above. Okay, moving forward to that next question. Let's take a look. We want to start solving equations now. So solve for x in the following equation. What's happening here? So we have 1/2 minus 1/3 x equals 4/3. Now, if you take a look at this might look scary, and the main reason people say it's scary is because you see a fraction. And there's a simple way to take care of that, and it's just finding a common denominator. What is our common denominator here? Well, notice we have 2 in the denominator here, 3 in the denominator there, and a 3 in the denominator there. So 3's, those two are the same, so we don't have to worry. 3 would be the common denominator with that. But then when we toss in a 2, that means 2 times 3, which is 6, would be our common denominator. And to make this equation a little bit easier and get rid of the fractions, what we'll do is we'll multiply by what would be the common denominator that we needed to get anyways. This is not the only method, but it's going to make your life a lot easier. Okay, so when we take this, we'll take the 6 times that 1/2 minus 1/3 x on the one side, and we'll take the 6 times the other, because if we do some operation to one side, we have to do it to the other. So we're doing that to both sides. Now we can distribute the 6 to both terms. So 6 goes to 1/2 and 6 goes to that 1/3 x. So 6 times 1/2 is just 6 divided by 2, which is 3. And then 6 times 1/3 x, well, that's just 6 divided by 3, which is 2x. And then we have 4/3 times x. Well, you can cancel off that 6 with the 3 and you're left with 2, so this whole thing equals 8. So notice now we have negative 2x. If we subtract 3 from both sides, so you get 8 minus 3, and the 3's would cancel off over there. And so we have negative 2x equals 5. And so that means x equals, well, what do we do here? We divide both sides by negative 2, the negative 2's will cancel, and we're left with 5 divided by negative 2. Or another way to write that is just x equals negative 5/2, or x equals negative 2.5, whichever you prefer. Okay. Moving forward from here, let's solve another equation. So solve for x in the following equation. You have 3 over x minus 2 equals 1 divided by x minus 1 plus 7 divided by the quantity x minus 1 times the quantity x minus 2. All that's appearing in the denominator right there. So when we take a look at this piece, What do? Well, it's very similar to what we did before. And notice we have a common denominator. You have an x minus 2 factor here, so we've got to get rid of that. We have an x minus 1 factor here, so we got to get rid of that. And then we have an x minus 1 quantity and an x minus 2 quantity, which happen to be the other two that appear over there. So what we'll do is multiply both sides. So by this x minus 1 times that quantity times the x minus 2 quantity. And so then we'll do 3 over x minus 2 equals, and then same thing, we have to do it on both sides. X minus 1 times x minus 2, that quantity times 1 over x minus 1 plus 7 over x minus 1 quantity times x minus 2, that quantity there. Alright, so when we take this over on the left hand side, hopefully we'll notice the x minus 2's will cancel, and we're left with 3 times the quantity x minus 1. So now on the right hand side, remember you have to distribute this to both terms. So I'll actually write it out for right now. It's going to be somewhat tedious, but not too bad. So we have that x minus 1 quantity times x minus 2, that quantity, all times 1 over x minus 1, plus the same thing, we have x minus 1, that quantity, times x minus 2, that quantity there, times our 7 over the quantity x minus 1 times the quantity x minus 2. Alright, so now it's time to kind of simplify. Well, on the left hand side we can distribute the 3 to both terms, so you get 3x minus 3 equals. Notice our x minus 1's cancel, so we're left with 1 up top, so this goes 1 times x minus 2, which hopefully we recognize is just x minus 2. And then we have x minus 1's cancel, and the x minus 2's cancel, and so we're left with plus just the 7 on top. So if we simplify this a little bit more, you get 3x minus 3 equals x minus 2 plus 7, so that would be x. When we add negative 2 and 7, that gives us plus 5. So now we can subtract x from both sides. You get 2x minus 3 equals 5. So we subtracted the x from both sides. And where do we go from here? Well, add the 3 over. So 2x equals 5 plus 3 is 8. Divide both sides by 2, and so you get x equals 8 divided by 2, so x equals 4. And if you really aren't sure, you can always check it, plug it back in, see what happens. Okay, if you plug it back in, you should get the correct answer. You have calculators if you want, so you can use them. But x equals 4, find our final solution there. So moving forward to the next problem. Nope. Let's see if I can move it forward. There we go. Alright, solve for x in the following equation. X squared minus 9x equals 22. So you might be thinking linear equations and things like that. This is a little bit different. This is actually a quadratic equation. The reason why we can tell it's a quadratic, you have that square. So that square right there and all the rest are less, so this is a quadratic. So usually in linear equations we try to get the constant over to one side and the variable over to the other. So with this, though, we have a couple different methods. And the thing that we'll have to do first, though, regardless, is move all the terms to one side. And so that's what we'll do first. And now, you actually have some options. In this case. Not always, but in this case you do. So what happens is you have this quadratic formula. It's a beautiful thing. You can actually use it every single time and it'll solve any quadratic that's tossed your way. The only bad part is sometimes the numbers are nasty and you're having square roots, and trying to find square roots of these numbers are kind of ridiculous. In certain cases, as in this one, it is easier to factor and it's a lot more efficient. You just have to be good with the factoring process. And that's what we're going to do. You can use a quadratic formula. You can check to see if you get the same answer. But we know that we have x's as both of our terms there, and now we got to look at factors of 22. And in fact, we want to be negative 22, so to be a little bit more careful. Factors of negative 22. And you don't have to write this out if you feel comfortable without it. You have negative 22 and 1, and then obviously negative 1 and 22. Other factors of 22, though, notice we can factor out a negative 2. So negative 2 and 11, or negative 11 and 2. And so we're trying to see, this one's a little bit easier where we don't have a 2x or anything like that in front. So we're just looking to see if any of these sum up to negative 9. And that will be how we actually list them. So in this case, negative 9, notice, is negative 11 plus 2. So if we take those two factors, we put in negative 11 and we put in plus 2, notice you get equal 0, and you are good to go. So now how do we solve it from here? Well, in order for a product of two things to be equal to 0, that means one of these pieces has to be equal to 0. So we have either x minus 11 equals 0 or x plus 2 equals 0. So in this case you add 11 to both sides and you get x equals 11. In this case you subtract 2 from both sides and you get x equals negative 2. So our solution is actually two possible solutions. And this is one of the few possibilities that we have for quadratics. Remember, quadratic equations, you should either have two unique solutions. One solution, basically we call it a root of multiplicity there. And then the other case would be no real solutions, which in that case you're talking two complex solutions. So those are our scenarios whenever you have a quadratic. But notice how this broke down nicely to linear factors. So that's something I want to try and illustrate here. When you have a y cubed plus 2y squared minus 9y minus 18, what's happening? Well, notice this is actually one we simplified earlier. We factored out a y squared of the first two terms, and we were left with a y plus 2. And we factored out a negative 9 of the second two terms, and we were left with a y plus 2. And so we could then write this as y squared minus 9 times y plus 2, because both of those terms were multiplied by that. And y squared minus 9, if you recall, becomes y plus 3, y minus 3, and y plus 2. Well, the beautiful thing here is, as we know before, if a product of three things are going to be equal to 0, at least one of those three has to be equal to 0 itself. So you have three different equations. Y plus 3 equals 0, y minus 3 equals 0, and y plus 2 equals 0. So subtract 3 from both sides in the first one, you get y equals negative 3. Add 3 to both sides in the second one, you get y equals 3. And then subtract 2 from both sides in the third one, you get y equals negative 2. Okay. So now moving forward from there, where do we go? Well, we have our solution. It's those three values, and you get y equals negative 3, negative 2, and 3. And I just wrote them in increasing order just for kicks there. You didn't have to whatsoever. But that's another way to solve now a cubic polynomial. So if you have grouping, you can do pretty much the same idea of factoring and set each factor equal to 0, and you're good to go. So let's see another type of equation we can solve, and what we're going to use here is the quadratic formula. So with this, how does the quadratic formula work? Well, if you have ax squared plus bx plus c equals 0. If you ever heard the Pop Goes the Weasel song, that's the way we can kind of sing this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Just sing it to yourself. You do it enough times, trust me, you'll get it, and you'll be good to go there. So now moving forward on this problem, what's your a, what's your b, and what's your c? And you could try and factor, see if that works out. You might have a hard time on this one though. So a equals 3, your b equals 5, and notice it says plus c even though we have a negative value there, so that means c actually equals a negative 8. So when we actually work through this one, what's happening? Well, you get x equals, it goes negative b, so that'd be negative 5 plus or minus, and we'll talk about that plus or minus in a second here, 5 squared minus 4 times a times c, so 4 times 3 times c, which is negative 8. And then all of that is 2a. So 2 times 3. Okay. So what does this become? Well, this is negative 5 plus or minus the square root of, that's 25. So minus and a minus makes a plus. And then let's do this. 8 times 4 is 32. And then 32 times 3 is going to be 96. So that should be a little bit nicer for us to deal with. And then we have our 6 there. Now let's see what happens. Well, if you notice, actually we get something that's pretty nice. Get negative 5 plus or minus. Well, wait a second. This is a square root of 121 divided by 6. Okay. So what's the square root of 121? That's just 11. So negative 5 plus or minus 11 divided by 6. Now, this gives us two solutions. So we get x equals, that plus or minus tells us one solution is negative 5 plus 11 over 6. And the other solution is negative 5 minus 11 all over 6. Okay. And the reason why I wanted to use the quadratic equation, because I wanted to show something how we could do this very quickly. Or quadratic formula, I should say. So notice this, by the way, is, let's write that over here. Negative 5 plus 11 would just be 6 over 6, which equals 1. And negative 5 minus 11, that's going to be negative 16 over 6, which we can reduce down. So notice you have, both of those have a common factor of 2, so this would be negative 8 over 3. Okay, so we have negative 8/3. And that would be our final answer. We're good to go. But notice, if we go back to our original, and you know how to factor real quick. So notice all that work there, right? You can recognize that you have a 3x and an x in this case. Okay? And then we're looking for factors that make negative 8 but add in positive 5. But so notice if we do plus 8 right here and a minus 1 right there, set each factor equal to 0, what happens? We get, in this case, 3x plus 8 equals 0, or x minus 1 equals 0. So you get x equals 1, or in this case you get 3x equals negative 8 and x equals negative 8/3. So just trying to illustrate that you can do some of these extremely quick if you are very good at your factoring. Right? Notice we didn't have to take all those steps trying to do all the square roots and all that jazz. If you know how to factor, it cuts down your time quite a bit. But there will be occasions from time to time when we won't be able to factor whatsoever. Right? And so it seemed like that in the first one, but now we got 3x squared plus 1 equals 5x. So first off, kind of tricky, but it goes 3x squared minus 5x plus 1 equals 0. So notice we have, in this case, what is our a value for our quadratic formula? A value equals 3. What is our b value? Our b value equals 5. What is our c value? Our c value equals good old-fashioned 1. So now we have x equals, it goes negative b, oh I'm sorry, I wrote b equals positive 5. B equals, you saw it coming up right here, negative 5. So x equals negative 5 plus or minus the square root of negative 5, the quantity squared, minus 4 times a times c. So a is 3 and c is 1. And then all over 2 times a, so that's all over 2 times 3. So we made a minor change here, and what happened? Well, this thing went kind of haywire on us, because notice what's happening underneath the root. So we get 5 plus or minus the square root of, when you square negative 5, that gives you 25, minus 12 all over 6. So x equals 5 plus or minus the square root of 13 all over 6. what happened there? Well, you don't have a nice perfect square root on square root of 13. So in this case, this equal, well, let me put what this is as our solution set. So x equals, we have two solutions. You have 5 plus the square root of 13 all over 6, and then 5 minus the square root of 13 all over 6. And actually, if you wanted to factor this thing, so from that step on forward, what that tells you, just a little FYI, that means your factors are x minus 5 plus square root of 13 all over 6 and x minus 5 minus square root of 13 all over 6, which I highly doubt we saw right away, right? That's what this stuff is telling us, how these things factor when we find our solutions. Okay? So keep in mind the quadratic formula, it can be nice, it can be used like in the previous case where we could even find out a solution factoring, and factoring might be quicker in some cases. In other cases though, it might be difficult to factor, like this one, and almost impossible to come up with those values when we're first learning this stuff. So, oh, one other piece too, you can actually come up with complex solutions as well. So if you actually changed the 1 in this case to a 9, you'd end up with what's called a complex solution where you have i's involved. So those complex numbers, something to keep in mind. So complex numbers, those are numbers of the form a plus bi, where a and b are real numbers. You might be asking, well, what is I then? And sorry for the run-on sentence here. I equals the square root of -1. Okay, so you have cases like that. Examples. So you can do 5 minus 3i, 7 halves plus 3/7 i, right? Things of that nature. You could just have 0 be that a value, and so you could just have some multiple of I, and you could have 0 be the b value as well. And so even real numbers, they're sitting inside of the complex numbers. So something to keep in mind with that as well. Alright, so now let's get into inequalities. Solve the following inequality for x, and then we want to write our answer in interval notation. So how do we go about doing this? Well, first things first, just like if this were an equal sign, we want to start trying to get all the x terms on one side and everything that's not an x on the other. So what we'll do is we'll distribute the -3 to both terms. So you get -6x minus 3 is greater than -2x minus 8. Have to distribute the -2 to both terms. Now you can get all your x's on one side and all your constants on the other, just like you do for any linear equation there. So what does this mean? Well, if we look at, in this case, what's happening, we can move all our -6x, move that over, and so the way we do that is add 6x to both sides. So if we add 6x, you have -2x plus a 6x, that makes 4x minus 8 over here. We have a -3 over on this side. Now add 8 to both sides, so notice we get 8 minus 3, which is 5. So 5, and then we have a 4x sitting right there. Now here's the caveat. When we divide by a positive number, we just divide both sides, no worries whatsoever. So if you move -2 to the left, on the other hand, you have a negative. When you divide by a negative, you actually switch the inequality. So if we had greater than, we're going to switch it to less than. If we had less than, we're going to switch it to greater than. So when you're dividing by a negative, that's when you switch an inequality. Addition, subtraction, doesn't matter, but when we divide by a negative number, that's when it does. So since we don't have a negative number we're dividing by, there's no reason to make any changes. So you have 5/4. When we divide both sides by 4, we get 5/4 is greater than x. Or another way to read this is x is less than 5/4. So for example, 0 would be a number that satisfies this. So if you draw your solution on a number line, what's happening here? So if we have 5/4, first off, do we want to include it? Well, no. So the reason why, we don't have a greater than or equal to, so we don't include it. And now, which direction do we want to go? Do we want to go to the left or do we want to go to the right from here? Well, if you look, think of numbers that would satisfy this. Which side of it? So plug in a number. Okay, would 7, for example, is 5/4 greater than 7? No. So 7 is to the right of 5/4, so that means that doesn't satisfy. Well, what about 0? When you plug in 0, is 5/4 greater than 0? Well, yes. So that tells us that we're going this direction with our interval. Okay. So now to write it in interval notation, how far to the left do we go? Well, we go all the way to negative infinity. Okay. Where do we stop? Well, we stop at 5/4. Now, do we want to include 5/4? Yes or no? Well, notice there's no equal to symbol down below, so no. So that means our solution to this is just the interval, the open interval, negative infinity to 5/4. Alright, moving forward. Solve the following inequality for x. Write your answer in interval notation. So we have x squared minus 5x minus 24 is less than or equal to 0. So the way to solve this, you kind of treat it the same as any quadratic. If possible, you factor. So, and that's what we will do here. In this case, the factors aren't too bad. Notice factors of 24, you could use 1 and 24, but notice those don't add. And we're thinking positive and negative in any combination. So positive 1 and negative 24, or positive 24 and negative 1, that doesn't add to negative 5. Then we go positive 2, negative 12, and then positive 12, negative 2, that doesn't add to negative 5. Then we can go positive 3 and negative 8, and we have a winner-winner chicken dinner. So positive 3 and negative 8 are our ticket. So now what does this mean in terms of how we're going to solve this thing? Well, what we do is, first off, we set it equal to 0. I know that sounds kind of counterintuitive, but notice that is even involved here. So we go x plus 3 equals 0, and x minus 8 equals 0. And so notice that means x equals negative 3, and x equals positive 8. So if we were to create a number line, we know that those two values allow this whole equation to be equal to 0. And that's a possibility here. So we have negative 3 and positive 8. And since equality is allowed, we want to close those circles. Okay? And in that case, what happens? Well, now we have a way to break this down. And some people use that good old sign chart and things of that nature. And what we're going to do is test intervals. So the intervals, and then we're going to look at what happens to each factor. X plus 3, x minus 8, and then the multiplication of the two. So you might be asking, what are our intervals? Well, our intervals are broken up by how we made our number line. So notice we have an interval from negative infinity to negative 3. So that's our first interval that we're going to check. Our second interval is from negative 3 to 8. And notice I'm putting open intervals for right now, but that won't necessarily mean it holds in the final answer, because remember, we have equality, so we will have some square brackets involved. This is just checking everything other than those points, because we know those equal 0. And so then we go a to infinity. Okay, so what happens? Well, we pick a number from the given interval and plug it into each equation. So let's pick a number, let's say for our first one, negative 5. We picked in that interval. Just picking a random number, you could pick negative 7, you could pick negative 1 million. It doesn't really matter. All we're caring about is it positive or negative? Because notice this less than or equal to 0, that's the dividing line between positive and negative numbers. And we're looking for the times that this is actually negative, our whole multiplication there. So notice, when we plug negative 5 in here, you get negative 5 plus 3. So negative 5 plus 3 is negative 2. Well, all we care about is the negative, right? Plug a negative 5 into x minus 8. Negative 5 minus 8, that's negative 13. But all we care about is the fact that that's negative. Now think about this. We're multiplying a negative number with another negative number. What does that make this? Well, that makes our final quantity positive. And so what I'm going to do is I'm going to indicate that by a positive up top here. Okay. In our next one, we want to pick a number between negative 3 and 8. The easiest number to work with in that case is 0. So we're going to plug in 0 into each part. So when you plug in 0 into x plus 3, you get 0 plus 3, which is 3, so that's positive. When you plug in 0 to 0 minus 8, you get negative 8, which is negative. A positive times a negative makes a negative, and so that whole quantity is negative, and so we'll list it that way. Last but not least, pick a number greater than 8. Let's do 10, just for kicks. 10 plus 3, that's going to be a positive number. Okay. And then 10 minus 8, that's going to be a positive number as well. So positive times a positive makes a positive. So you might be thinking, well, what's the purpose of this? Well, notice we're looking for when this whole quantity right here is negative, because it's less than or equal to 0. So negative or 0. And the only place where this is negative, if you look, is on this interval negative 3 to positive 8. Okay. So when we're drawing this in, we're going to take that and make a solid line right in here. That is our interval. Notice we want to include those endpoints. So where do we start? Well, we start with negative 3 because that's the first value, and we're including that with a bracket there. Reason why? Because it can equal 0. Where do we stop? Well, we stop at 8. And then we close that off because that is included as well. So at the end of the day, this is our final answer for our interval. We get the interval from negative 3 to 8 where we're including both of those endpoints. So hopefully this answers some of your questions. If you do have any more questions, I didn't see any come up in the chat, but if you do in the future, I'll hold a few more YouTube live sessions, and just feel free to jump on in, ask questions if you ever do. Have any pop up in your head, or if you're watching a problem or something like that, just let me know, and that's what I'm here for. I'm here to answer those questions. So hope you all have a good rest of the day, and I will wish you luck on the upcoming exam. Let's see if I can find this here.